going, everyone? Today I thought I'd teach you how to see if your alternator is big enough for your car. So recently with my car, I've been having a problem. After installing some electric fans, it is too much for my alternator. Now, ways you'll know this is, for one, by your battery gauge will drop down. Too many electronic parts come on. And two, you might even have running issues where your car won't want to run as good because you're taking power away from the spark mechanism. How do you know how big an alternator you need? Because there's a lot of variations whenever you get to higher amperage alternators. So this will just tell you how to check how many amps your car is pulling from its electronic devices. All you'll need to do this is just a multimeter. This is $20 at Walmart, nothing special. Maybe some pieces of random wire assortments, and that'll just be for connecting up the battery. So first, what is amperage? Think of electricity as water. So the amount of water coming in is current. The pressure of the water is voltage. So everything in your car is going to be 12 volt. So imagine a creek, all right? And you got slow moving water. We can say the speed of the water to be 12 volts. However, there's a lot of water coming at you, so it's medium current. Now let's take a big river. That river is going at the same speed, so the speed would be 12 volts. The river's moving slow, it's 12 volted. Now but the river is way bigger than the creek, so there's a lot more water. That water is current and amperage are the same thing. Amperage is a measurement of current. So you're getting more at the same voltage or less. The best way to know what alternator you've got in it, assuming you have a stock car, is just look up the car model and it'll tell you. But let's say you've added a subwoofer and you've some lights, you've done some stuff. So let's see how many you're pulling and what alternator you should get. So as you can see in this car, I've got a extra fuse box over there, electric fan, LED headlights, a lot of different things that are electrical, and it's just too much for my alternator, which is down there, to handle. So we're gonna see how much this car is actually pulling. So the first thing you're gonna wanna do is turn your meter on. Now you wanna go over to amperage, and I'm gonna put it at 200 milliamps. I don't really know. Okay, editors, note what I'm saying here is incorrect. What I should have done is leave the black ground wire in the COM port there in the middle and moved the red positive wire into the leftmost slot. I messed that up. I ended up going back to the video and fixing it later on, but I just didn't want anybody to do it incorrectly off the start. So you want to break the neutral wire. So I've got the negative of this going to a vice grip, holding on to the clamp. Again, if you can do this less janky than me, then do it. And the other one goes to this wrench, which is trying to short out around the negative battery post with a thing on it. And I'm actually pulling 0.7 amps. I'm not sure from what. My test seems to be a little bit off. So one part that I failed to show you that I should have is that you're going to need a pen and paper, and this is because you're going to add up all of your voltages. So now we have everything ready to test. We have our notebook, we have the meter. I've got it disconnected at the moment, and we're going to start testing. Two things to note before you start testing: do not have the engine running, and only test one device at a time, and don't leave it running through the meter for all that long. So the first thing I want to do is check these electric fans. So now, you might have a problem because you're gonna have to find some way to jump start it because they kick on when the engine temperature reaches a certain temp. And that's how it is for one of mine, but one of mine is controlled by a switch in the car. Turn the switch on, and there is some sparkage, so a glove is recommended. So let's send to the alligator clip, and we're gonna run that voltage through the meter. Okay, so it requires, let me explain what you just saw there a little bit. You've seen it ramp up. At first it was like 14, then drop to 10. So fans acquire way more current when they're first starting up. So I'm gonna go with I mean, your electricity could dip a little bit when the fan turns on. That's okay. So let's go conservative and not go straight to 10, but let's say 11. So we'll do 11 and 11, because remember there's 2 fans, and at the max it's going to have 2 on it. So now we're going to turn that off like I talked about, one at a time, and we are going to turn the AC to high max. So turn the blower motor all the way up. Connect the wire. We'll call it at 13. And we're going to turn our headlights fully on, which for me will engage all these gauges. That isn't, the light in that ain't working for some reason. It'll turn on the dash lights. It'll turn on, my fog lights don't work because it's not hooked up, but I'm gonna add a little bit just when I do get them working. So to have a little bit of headroom. So if you plan to add some lights and you know what the current's gonna be, go ahead and add those. So got the headlights, LED bulbs, just got the little fan on them. We'll once again put that at 11. Now we are going to turn our wipers on full. And something to note with the wiper test, you probably don't want to destroy your wiper blades. So about 25 at the peak. Now there is some things that I would consider of less importance. Let's go over this real quick. The less important things. I'm not going to be factoring in things like window motors, as they're not used constantly. If you're driving, rolling your window up and down constantly, something's wrong. 2 would be the motors in your review mirror. Now this is an old car, so the level of tech in it is very low. But if you're testing this on a more modern chassis, there is probably a lot more things to test. Now the last thing I want to test is the radio. I excluded things that I would consider not 100% on the car. It's not 100% going. Like a lot of times you're going to have your AC on, your headlights. You're going to have your AC on, your headlights. You're going to have the radio playing. And that's pretty common. I would say those are 3 things. Oh, and you know, a radiator fan would be on. Obviously, the engine's getting spark, I'd assume. So you would think that the car should be able to support all that. So those are things that you're going to have on all together at the same time in a standard driving scenario. So you need an alternator. Well, I need an alternator. Your car varies. Of about 110 amps. Now, a Fox body comes with a stock from 90 something, whenever your car was, whatever, with a, I think, 75 amp alternator. So for me, this isn't going to work, and you might be wondering how I've been driving this car if it's that much over. Well, I usually only have one fan on, one on the switch that runs to a relay. I don't have the air conditioner turned on. You know, I usually drive in the day, the headlights are usually off. But like on my trip to Tennessee, we were trying to run some different stuff. It was raining, the windshield wipers were on, it was night, we were blaring music to go to Smokies and the Ponies. And, we were driving to Ponies and the Smokies. And yeah, the car almost died, and I had to just like frantically start turning switches off and freeing up some amperage. So let's talk about what this number actually means. It means you need a 110 watt alternator. 110 amp alternator. Incorrect. You want to go above and beyond the minimum. You don't want the minimum. So I think there's a rule called the 50% rule. What this basically means is you want your max capacity, standard max capacity, to be 50% of the total your alternator can put out. And I think that's the rule. It might be a little less. So personally, I'm going to get a 140. That's just what works for me. Maybe a 150, depending on what deals they have on like American Muscle. So I'm gonna go with 140, 150, but it very well could be different than you. An alternator is like anything else. It has an efficiency curve. So it's a very, you know what, fuck it. I'll just put up, I ain't gonna describe it with my hand. I'll put up on screen right now. You're looking at a alternator curve. So what you're seeing is it start lower at the bottom, and as the engine revs up, i.e. I think it's impeller of the alternator spins faster, it produces more electricity. It's the same as like if you ever had one of those like crank flashlights. The faster you crank, the brighter that bulb. I hope that you are able to diagnose your car with any issues you may be having that kind of fit the description of this. Or if you're looking to put in a killer bass system or some new fans or whatever LED light combo you're into, I hope this gives you enough information to start your next project. Stay safe.